We're going to go one more to remove the magic. What is your party affiliation and what age group do you belong to? So two different questions. So for example, subject one said, oh, I'm Democrat and I am in the group 29 to 40. Subject two said, well, I belong to some other group that you don't have listed here. And I am 40 plus. Subject three chose Republican and the age group 29 to 40. So imagine a long questionnaire, okay, like this. And subject after subject, person after person is filling this out. And here are my totals. 45 chose Republican, 73 chose Democrat, 10 chose other, and 38 chose none. As far as party affiliation, and notice party affiliation is the variable, and they are my, as a matter of fact, see these right here? What are these called? In the terms of what we've been describing, general terms, these are known as, the variable is party affiliation, but these are, what is it? They're definitely categories, but in relation to the variable party affiliation, these are known as factor levels. Yeah, right. So that's the factor levels show how things are. So these are the factor levels. Okay. Exactly. That's what they represent. Okay. And again, when we look at age, 55 in this group were 18 to 28, 29 were, sorry, 49 people were in this age group, 29 to 40, and 62 were in the 40 plus. So again, person after person just puts it, and this is just now summarizing everything. Okay. So notice, let's talk about the margins, because we're about to create this table. This is what is known as a two-way table or contingency table. But I want you to see where things come from. So the margins are, what's called the margins are variables. So the margins contain the variables separated. Okay. And a marginal distribution only focus on individual variables. So for example, if I had to fill out this table here, the only thing this information gives me are the totals. So for example, Republican, all I know was that right here, there were 45 Republicans, and Democrat, there were 73. Other were 10, and none were 38. So these numbers go right here on this table. When it comes to age, 18 to 28 were 55. So that 55 goes here. So again, notice 18 to 28, we come across 55 total. Here's 49 total. And finally, 40 plus, there was 62. If I add these up, what's my grand total? How many people were in this? Well, let's find out. So I'm going to add these up. 45 plus 73. I should have done the other one less thing to add up, but oh well. 30, nope, not 38, 30, 39, 30, 38, yeah. So there were 166 total. So if you add these numbers up, you should see that they come out to 166 also. So let's just do that for fun. I added this horizontal, but just for fun, just to make sure, 55, oops, no. 55 plus 49 plus 62. There you go, 166. So there were 166 people filling out this questionnaire. So you can see that these add up to 66 and these numbers add up to 166. Okay. So often you'll see that you're talking about, hey, a marginal distribution. Let me create a graph of it. Again, do you anybody know here what a bar graph is? I think might have mentioned it once, but it's just the one you see all the time in the news. So the marginal distribution just concentrates on the margins. So the bar graph, for example, let's say that I'm looking at the variable party. I'm going to go here. So then, for example, I would have here party would be like, for example, Republican, Democrat, other, none. So then we just create a little bar graph. So I'm going to go, this is 10, 20, 30, 40, 50, 60, 70, 80. So Republican, there were 45. So 30, 40. So 45 is about right there. So I create my bar graph to rise to 45. Democrats, there was 73. So a little higher up, 70 is right here. So 73 is right about here somewhere. And I'm doing my best to make the width of these things exactly the same or close to it. Looks like other, there were only 10. And none, there were 38. And there you go. There is the party affiliation. And this is, again, a bar graph of the marginal distribution. Right? So that's what this is, just the bar graph of the marginal distribution for party affiliation. Um, so again, this is a margin. That's a margin. And this is the margin up here too. So I have my margin here and the other margin is right there. So when we look at margins, the two variables are separated. Okay, so the margins contain the variables, but separated, right? And notice when you hear like in everyday language, when you hear the word "you're on the margins," sort of what does that remind you? What image does that portray to you? You're on the margins. You're on the outside. So notice you look at this table. Look, these variables have been pushed to the outside of the table. So so I'm guessing that's where that comes from. The margins. You've been pushed away from the center, from the middle of that table to the sides, pushed away. So these are the margins. Okay. So what goes in here? Well, we're going to find out in a minute what goes in those. Yeah. All right. So now a joint distribution focuses on how many meet conditions of a factor from each variable. For example, how many are, as an example, 18 to 28, and let's say Democrat. All right. So this would be as an example. So, for example, subject one is found in, where is subject one found in? when you look at that table, the one when it showed the different ones, where does subject one belong to? Yeah. What is it? So found in 29 to 40 and Democrat. So now I'm going to just do this part. Where is subject one here then? So subject one is 29 to 40 and Democrat. So subject one is right here. In this table, there's where subject one wound up at. They're 29 and 40 and Democrat. So this is now a joint. Okay, so this because now we're joining the variables. So joint means putting together, join, align. For example, where does subject two belong? When you look at that the table, subject two belongs to 40 plus and other. So now again, I come over here and subject two is 40 plus and other. So there's subject two belongs right there. And lastly, where does subject three belong? Yep. And right, 29, 40 and Republican. So subject three is 29 to 40 and Republican right here. Subject three. So in other words, all we're going to do is keep track of where they belong inside this table. Yeah, and at the end, what we're going to do, we're just going to count. So how many fit in this group? How many fit in this group? How many here? 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 How many? So this forms the joint. This area right here. This forms the joint distribution. So we don't want to separate the variables. We're trying to see so this is the first example of putting two variables together. So now we're more interested in two variables, okay? Comparing two variables. They happen to be categorical. So really the remainder of this class is now about comparing two or more variables. That's the end goal, right? So everything up to this point has been separate. Okay?